If you cannot solve this at a glance just by looking at it, then this lesson is for you. I'm going to introduce indices, that is exponents, and we are going to start that from the basic, from the scratch. Okay, so first of all, let's discuss what indices is all about. If you want to solve any question under indices or exponents, there are so many rules and regulations that govern it. We are going to start from the first law, and the first law of indices is called the multiplication law. The multiplication law. Okay, now what does this multiplication law state? This multiplication law states that a to the power of m multiplied by a to the power of n is equal to a to the power of m plus n. What does this mean? This simply means that when you have two numbers that are multiplying each other and both of them have the same base, okay, all you need to do is to pick one of the bases and then you add the powers. Let's do a practical example. For example, you have 2 to the power of 4 multiplied by 2 to the power of 3. Now we have the same base and they are multiplying. Note, there must be multiplication, okay? They are multiplying. So all you need to do according to this particular law is that you pick one of the bases and then you add the powers. So your solution will be 2 to the power of 7 if you are asked to leave your answer in index form. Excuse me. Now let's prove this. Assuming we don't know that this law exists, if we want to solve this, what we will write is 2 times 2 times 2 times 2, right, into 4 places, multiplied by 2 into 3 places, 2 times 2 times 2. Okay? Excuse me. So to leave it in index form, we are going to pick 1, 2, right? This is same thing as 2 times 1, 2, 3, 4, 5, 6, 7. 2 times 7, which is exactly what we have here. So that will show you that this law is what? Correct. Now we are going to solve some questions under this law. At the end, we are going to solve this. By then, you must have mastered the law very well. Though this is very easy, like I said. If you know this law very well, you should have solved it at a glance. Okay, I decided to bring the questions here, and the last one, we're going to solve this one last, okay? So I advise you stick to the end while we do this. Okay, so the first one said we should multiply 243 by 3 squared, okay? So this is how to solve it. For number 1, these are my solutions. So this says 243 multiplied by 3 squared. Okay, this is under index of exponent. What you need to do is to first of all change them in the same base. You know, remember what I said a base is, right? So let's put them in the same base. This is already in base 3. That is a signal that this can also be in base 3, right? Now this can be written in base 3 as 3 to the power of 5. Okay, so we can rewrite this as what? 3 to the power of 5 multiplied by 3 to the power of 2. Recall, in all this, you're asked to leave your answer in exponent form or index form. Okay, so this simply means because they are in the same base, we are going to pick one, then we are going to add the powers. That is 5 plus 2. So in index form, the solution is 3 to the power of what? 7. You can see how easy it is, right? So that is it for the first one. Now let's solve the second example. Now the second example is what? That one says simplify 5x squared y multiplied by 2y squared. Okay, now you are going to collect like terms. In this case, what are the like terms? 5 and 2 are the numerals, so 5 multiplied by 2 multiplied by, we have x, only one x, so we are going to bring in only that. Then multiplied by, we have y and y, so we are going to bring in y multiplied by y squared. Now anytime you see y, x without any exponent, it means that the exponent or the power is 1, right? So y is same thing as y to the power of 1. So we now solve. This is 5 times 2 will give us 10. Then we have x squared. So we are going to apply the multiplication rule here. This multiplication rule, we have y and y the same base and they are multiplying. So we are going to pick one y and we are going to add the power 1 plus 2. So finally the solution to this will be 10x squared y to the power of 3. Very easy, right? If this is the first time you're coming across this channel and you have watched to this stage, that simply means that you love what I'm doing. Please click on the subscription button and on your notification bell so that you'll be notified anytime I upload a new video. Thank you so much. All right, now let's solve the third one. The third one says number 3, simplify this multiplication multiplied by this. Okay, so this multiplied by this, that is 2c4 d squared e squared multiplied by minus 5c squared d to the power of 3e. All right, now we are going to collect like terms as usual. So it's going to be 2 multiplied by minus 5. Okay, multiplied by, let's pick c, anything concerning c to the power of 4 multiplied by c to the power of 2. Now multiplied by d to the power of 2 multiplied by d to the power of 3, right? D squared multiplied by d cubed. Then multiplied by e to the power of 2 multiplied by e to the power of 2 multiplied by e to the power of 1. Always put that so that you don't make mistake. All right, so this is equal to 2 times minus 5 will give us minus 10. So we pick one c, they're in the same base and they are multiplying. So we are going to pick one c and we are going to add the powers. So it's going to be 4 plus 2, right? Then we pick one d as well and we are going to add the powers, 2 plus 3. We are going to pick one e also and we are going to add the powers, 2 plus 1. So finally the solution is minus 10. C, we are going to add 4 plus 2 will give us 6. Then D, 2 plus 3 will give us 5. And E, 2 plus 1 will give us 3. And this becomes our solution. Interesting, right? Now to the Obenga, let's solve that last question. That is this one. So the question says we should simplify 5a to the power of 3 multiplied by 625 a d squared e to the power of 4. All right, now first of all we need to put them in the same base. Recall what I said. Ensure you put your numbers in the same base. Okay, so we have 5a to the power of 3, okay, multiplied by 625 is same thing as 5 raised to the power of 4. Okay, so we have a, we have d to the power of 2 and e to the power of 4. Now it's time to collect like terms. To collect like terms is going to be this same thing as 5 to the power of 1, right? So you're going to write 5 to the power of 1 multiplied by 5 to the power of 4. Okay, then multiplied by, let's pick a to the power of 3 multiplied by a, which is same thing as a to the power of 1. Then we have d to the power of 2 and e to the power of 4. So this is equal to, we are going to pick one base, which is 5. We are going to add the powers, which is 1 plus 4. Then we have a again. We are going to pick one base and we are going to add the power, which is 3 plus 1. Then d doesn't have a like term, so it's still d squared. And e doesn't have a like term, so it's still e to the power of 4. So this simply means 5 to the power of 5, a to the power of 4, d to the power of 2, and e to the power of 4. And this becomes our final solution.